Okay, so this is a guided lesson through chapter 7, section 1, and you have a packet that you should have in front of you, and it starts with mental concepts and concepts. And I'm going to step you through that, and there should be a second page with a brain on it, and then your assignment is also something we're going to talk about, and that's on the problem solving obstacles that you're going to do some work with today. So let's get started talking about this chapter to begin with. There's a video that I put on Canvas that has a man who has autism, and he's also a genius, and he talks about this kind of preconceived notion that people have about him because he grew up with Asperger's and autism. And he talks about his experience with that. So something kind of cool to watch to see, this chapter is really cool with that, and in that it talks about what intelligence is, and we kind of have some conversations about what intelligence is and what it isn't. And that's something I really want you guys to sort of be thinking about as we go through this. And think about what your own preconceived notions are of people that, as you've grown up, have acted a little bit different. And did they have one of those disorders, and did you treat them differently because of that and thought about their intelligence differently? When we think about cognition in reference to thinking and intelligence, these are all the mental activities that are involved in acquiring, retaining, and using knowledge. When we think about dimensions of intelligence, it's the analyzation of situations and problem solving and decisions and use of language even that can show somebody's intelligence. And then when we think about thinking, that's involved in all of those mental activities, including memory, reasoning, planning, and even daydreaming. So when we think about intelligence in reference to what all the things surrounding it in terms of cognition, it's really that analyzation that we're looking at of what people do. Also with thinking, we manipulate mental representations in order to draw references and conclusions and so forth. So thinking can involve that as well and can show somebody's intelligence. Mental processes are directed towards some goal or purpose or conclusion. So again, thinking can be that problem solving piece that's part of intelligence. Okay, so what I want you guys to do is take the sheet there, the packet, and you're going to make a tree map of things about mental images and concepts. And there's some important concepts in here and words and vocabulary words that we're going to draw some pictures with. So here's what I want you to do. On the mental images underneath, this is the things that you're going to write. First of all, and you can pause the video. I'm going to keep going, and you can pause the video when if you need some more time, okay? So under mental images, as we review what those are, these are mental representations or objects or events that are not physically present. So the things that we could imagine. So visual pictures or sensations that we create for some kind of cognitive task. So what I want you to do, and then you can pause the video, is draw a picture of your ABCs and smelling fresh popcorn. Those are things that could relate to mental images. So saying your ABCs, you can almost imagine those in your head, but it's not a physically present object, but we have a mental image of what ABCs are, and somebody's saying their ABCs, but we don't actually see the actual letters. And then again, a sensation can also be that too, a cognitive task. So the smelling of fresh popcorn, we have a mental image of what that might look like, and so forth. Okay, and then also under mental images, write down what was found in Koslin's study of the fictitious island. This was something that was out to the side in your book. And what we find about mental images is that when we're scanning a mental picture in the brain, it's the same as a visual image. And so when we actually are scanning something, it's the same as a visual image. And what that means is that the greater the distance between 2 points that you're trying to scan, the longer it takes to scan a mental image on a map. And that's what they found when they did the study on the fictitious island. Mental images are involved in thinking using the manipulation of mental images themselves. So thinking uses mental images and the manipulation of that. And as you're kind of contemplating things and problem solving, you kind of create these images in your mind. And what's kind of interesting when you think about how when you're trying to think about what something is, the more distance, rotations, difficulty it takes to mentally manipulate something, the more time it's going to take to figure out a problem or what something is. And so that is part of the difficulty with mental images. It's not like a photograph. Photographs are like memories or visual images we use to figure out problems, but are subject to error. With mental images, when we're trying to figure out something like that, if we rotate, as they did in some of the experiments, the more difficult it takes to try to figure out what something is. Okay, so and again, you can pause at any time to fill out your tree map. With concepts, concepts is a mental category we form to share and to group objects, events, or situations that have similar characteristics. And under concepts, you want to save some room because, as you know from reading your textbook, you have natural concepts and then we have phototypes and all that kind of stuff. So we're going to actually branch off in this one even further. Concepts reduce the effort it takes in thinking because, again, like we do with memory and with clustering and associations, we kind of categorize things, so it's easier for us to think through something. We don't have to recreate, categories every time because we already have categories that we have. For instance, you might want to draw a picture of food, and under food, you may put down things like fish, fruit, and crickets. And again, I put crickets in there because crickets is a cultural thing. And we don't eat crickets in this country. We wouldn't maybe consider that food in our own family, but somebody around the world is going to consider that food. So the concepts that we have can be very cultural based, societal based, and also individualistic based. Okay, also under concepts is it helps us organize things into main and subcategories. So for instance, you could draw a picture of furniture, large picture of furniture. And then under that, you would have chairs, which are also furniture, but then there's different types of chairs, and then beds, there's different types of beds. So all of that are concepts that we have. So again, you can draw any kinds of pictures of, a main category like food, and then you put down poultry, fish, those kinds of things. Those would be the types of things that would be under that concept. Now, when we talk about mental images, I want you guys to go to the brain section. All right, the picture of the brain that I gave you. And we talk about mental images and the brain, and we're going to go back to our tree map in just a second. The question that was presented in your book was, do mental images activate the same part of the brain as perception? Because mental images are things that we're like creating in our own mind, and would that be also perception? And so they did find that perception and actual mental images do happen in the same place. And so they did a study on, where would we see faces and places in the brain? So that's where you're going to take your brain picture that you have. And I already put the parahippocampus and the pisiform gyrus on there as well and labeled those, but go ahead and put down which one is which, okay? Very simple. Look at the P in parahippocampal. All right, that begins with a P, that's places, so P, places. So your PPA area is that green area there, and that is the place that lights up when we actually think or look at a place. Now F, the fusiform gyrus also begins with F, so faces F. Your FFA is your facial area, and that's the place, and you can see it's in the parietal lobe, which are where we use perception, and it's where we see faces. So you're going to want to jot that down. Now in the middle there, go ahead and you can highlight that in the same color you highlighted your studies on the brain we did in class. And you're going to see that we have a study that's done this, and it's Kathleen O'Graven and Nancy Kanwasher, and they did MRI studies, and they showed that the same area in the brain between imaging and perception, so when we perceive something and when we imagine something and we see an image of something, is both seen in the PPA and the FFA. The only thing they found is that perception had a stronger activation, and it was really distinct enough, which is really cool, where if you were looking at a picture of something and they just looked at your MRI, that it was strong enough that they could actually tell which object you were looking at, a face or a place or whichever. So go ahead and finish up your brain and then go to the next slide. What's really cool is not only is faces and places, but we also have different places in the parietal lobe where we can see shapes and word forms. And so you can really see that. And now it's different from faces that we've discussed with split brain. Okay, that's where we process them, but this is where we create and see those images first, and then the processing happens. Okay, so this is different than where we talked about where you see just faces on the right hand side and it's processed in that direction. Okay. Okay, let's go back to your tree map, and what I want you to do is under the word concept, you have a couple of things down, and I want you to create a couple number of branches there. Okay, and so under the words beds and chairs, or those pictures that you did, go ahead and create two branches. Okay, one's going to be formal concepts and one's going to be natural concepts. So underneath that, put on the left-hand side one, put formal concepts. Formal concepts are things that follow rules. They're rigid, they're logical, and they don't really have any kind of manipulation to them. They follow a rule or features. So a picture that you could draw there to go with formal concept is a geometric shape. There's no ifs, ands, or buts what a square is. Okay. Also things like solid, liquid, and gas. Those are all have specific concepts and rules that make them a solid, liquid, and a gas. So those could be things and pictures that you could draw under formal concepts. Now again, you can pause at any time. And now on the other side of the branch, okay, you are going to put natural concepts. Okay, and Eleanor Rush made this up, and a formal concept is a little bit more fuzzy. It doesn't really follow a rule, all right? And it could vary depending on where you live, all right? So at this point, your tree map, I'm going to draw this out for you, should look like this. Whoops, sorry. Concepts, got some things, and you've got formal and natural. It might be backwards, formal and natural. And right now you've written down here and you've got some pictures going, and then under natural you've got some things and you're going to draw some pictures here. Okay, then the next one we're going to actually put under natural, and that's going to be 3. So I'll get to that in a second. Okay, so under natural, you can draw a picture of a vehicle. A vehicle could be considered a sled or a car, and some members of some societies might think one concept is better than another, and it also is very cultural based as to what a vehicle is. So vehicle is a very broad topic, and those are the things that when we're thinking about, if somebody says, what's your favorite vehicle? And you're like, well, what do you mean? You know, what's my favorite car is a little bit more specific, but vehicle is more like a natural concept because it's a little bit more fuzzy. It doesn't have a lot of rules. Because someone in another country, and that's when we like kind of talk to people in other cultures, and they may say sled, and you're like, oh, that person's doesn't know anything. Like, you know, what kind of intelligence do they have? And that's the differences there when we run into people from different cultures that have different concepts of what things are, and then we kind of judge them on that. And that's the interesting part about concepts and intelligence, and the reason why all these things are placed here in this chapter is because all those things lead to how people solve problems, think, what they say. That's why language is in this section. And then that all leads to how we sort of view them in terms of intelligence. Okay, so this again is going to branch off of natural concepts. And so we're going to talk about 3 things. First thing is going to be prototypes. Okay, so our concepts, where am I at? Our concepts here under natural. All right, you're going to put prototypes and what a prototype is. So a prototype is something that you compare, an example of a concept that you think fits that rule just, best. So under natural, it makes sense because, a square is a square. That is a formal concept that no one can sort of disagree with. A vehicle is something that somebody could. So what is your best prototype of a vehicle? So it matches, if we match a prototype or a concept or a new image to a prototype, it's easier to identify it for us because we're basing it off of what we think is the best example. So if you think, what's the first thing that pops in your head when you think of the word fruit? A lot of people say apple. You may say orange, and that's your concept of what a fruit is, okay? And so that's when we can come into disagreement. So then you take apple and then you compare it to an olive versus a coconut. Which one is a fruit, okay? Now the second concept under natural concepts is exemplars. And this is not like that we don't use a single best like a prototype. We use a variety of things, and we use memories and different examples. So exemplar is like an example, different examples that we have of a fruit. So if you're looking at an olive, you may compare it to your prototype, which is an apple, but you'd also compare it to all the exemplars like a fruit and an orange and a peach, and you're like, what is an olive? Like, what is it? Is it a fruit? Is it a vegetable? And then you make that determination based on that. And then the third thing under natural concepts is the idea of incongruity. And incongruity is what creates some kind of comic sort of relief when we look at concepts. And it's the putting together of two concepts that we don't think should match together. So in the book they show the cartoon of the cats and the barbershop, and that really creates a lot of humor. All right, so that's the last thing that's under natural concept. And here's an example of an incongruity. A tree in a bathroom, and then there's men and dogs. Like, it's all sort of mixed up, and it kind of looks funny, okay? And that the dogs are going to obviously pee on a tree, right? And humans don't do that, but it's kind of like, sort of like that same idea. So that's where we get that humor, is when our concepts there's a juxtaposition of those together, and we create humor with them. Okay? Okay, so that's your tree maps in your brain. All right. The last part of the assignment today is to look at the problem, the major solving problem and major issues there. And there's a packet that you're going to have, and you can print out if you're absent or virtual. And you're going to define the strategy in your own words, and then you're going to give an example in your own life of when you've encountered that concept or used that. And again, we're using that elaborate rehearsal. Some of these concepts are used all the time. Availability of heuristics is almost always on an FRQ. I've seen it several times on it. It's on the test. So this list of vocabulary and these ideas are really important, okay? I'm going to go through each of the vocabulary words. So if you need it, you can stop the video at this point as well, if you want to, and just go ahead and do that assignment. But if you want to go over each one of those concepts, write down the question or the definition in your own words after I've said it, and then create an example. You can certainly do that and pause and play the video. So let's go over each one. Okay, trial and error. And I have a couple that are out of order because I put heuristics together, and I'll tell you what that is. So trial and error is the use of a variety of possible solutions. And that's, again, you've tried this tool, trial and error, kind of fail again, and then you finally can succeed. And then this, of course, is really time consuming because you're trying to use it, any possible things and not like the best possible. So that's the only thing that comes with trial and error. Algorithms is a certain method or step-by-step systematic process that you use to solve a solution. This is time consuming and not always practical depending on what's going on. So math formula would be one, but using all combinations to open a lock, would be way too time consuming. And so that procedure to open and so forth, and that trial and error, like all that stuff would take way too long to do that. So that's not the best problem solving method. Okay, and then we have the general idea of heuristics. Heuristics is really commonly used, and it's a general rule of thumb that may or may not work in a certain situation. And it definitely simplifies the problem and make it less difficult and so forth. And it reduces the number of possible solutions by using a pattern of information. And then once you kind of whittle it down to certain solutions, then you can use trial and error, and that way it's a little bit quicker. So an example of this that they gave is using the search box on a computer program instead of searching all topics. You're kind of like streamlining that down to a more manageable amount of information. Types of heuristics that are in your packet as well. you have sub-goals. So what's an example of breaking up a problem into, or a task into goals? So if you're writing a term paper, you find the topic, the research, the organize, and then you organize, write, and edit it. So those are all sub-goals. Working backwards is like budgeting. You start with an endpoint and then you kind of step backwards. So if you know you have $2,000 a month, what are the things along the way? Then you kind of work backwards to see if you can stay within that budget. And then flexibility, recognizing that strategy, some strategies might not fit a solution and you may have to switch to another one. It's not a single best solution, but it does save time a little bit because we kind of recognize that, that rule of thumb may not always apply. And so we need to move on to like more simpler ways of solving the problem and so forth. People that are on the autism spectrum like have a really hard time with flexibility. They're very inflexible with their thinking and they don't really tend to move on from a strategy unless they have vetted it out. So it's very difficult. They may be really time consuming when they solve problems because of that. Okay, availability heuristics is sort of the ends of the packet, but I put it here because it is heuristics in general. This is again the one that you see a lot on the test. And this one's kind of interesting because it's about us overestimating the likelihood of some event happening. And you can see the example there. Somebody's watching something on TV about shark attacks and then they go to the beach and they think it's going to happen to them, even though that is a very rare event, and so forth. It can be very vivid and we sort of overestimate the likelihood that it will happen to us. And part of this is that we see the frequency of it. And if you look, all the information, like on that circle I gave you, all the information sort of out, but then you're kind of centering it on just a small amount of information that you get, like one TV show that you watched, and you think the frequency is up, and so does the media says that to you, and it's a very vivid and negative image, and then we think like just that little bit of information, it's going to happen to us when we go to the beach. So the less accurate of our memory of the event reflects the actual frequency of the event. So once we get that inaccuracy of our memory, then we get the less accurate of estimating that the likelihood that's going to happen to us. It's used more by people relying on their long-term memory to determine the likelihood of events occurring. And so when they do that, they tend to get things a little bit wrong. Another example is winning the lottery. And that when you see that person winning it, you think it's possible that you can when it's so rare. Okay, and then representative heuristics is comparing to a prototype and then having a false or inaccurate judgment about something. We fail to consider possible variations from that actual prototype, and we fail to consider the approximate number of prototypes that actually exist and so forth. The example that you see there is the two people there, the woman in the bathing suit and the man. Who do you think went to Harvard? And the answer is the woman on the right. She is a swimsuit model and she's a economics major. The gentleman that you see there is smart, but he didn't go to Harvard, although he looks like he did. So we have this sort of general representative, population that we would see. So if you look at this, so, would a police officer be more likely to think a mom with a baby seat in a minivan is speeding or a teenager in a red sports car? There's a prototype of a speeder that we have in our mind, and they most likely will pull over that teenager in a red sports car because they think that they would speed more than a mom in a minivan. Okay, next one's for problem-solving strategies. Insight, sudden realization of how, what the actual results or problem, like the solution is. And then intuition is coming to a conclusion without any conscious awareness of what's going on. So when we look at the two stages of intuition, we have intuition guiding stage, where you perceive a pattern in the information, not consistent, not consciously, and it's based on your expertise, okay, or hunches and things like that. Accurate intuition hunches need knowledge and experience, so that expertise guides our intuition. And then integrative stage of intuition becomes conscious because a hunch or hypothesis. So a representation of the pattern becomes conscious, and then the conscious analytical thought takes over, where then you systematically prove or disprove your hypothesis. So in intuition, the expertise takes over unconsciously, and then with the integrative stage, then you bring it into consciousness and you actively work through and see if that hypothesis is true. That's what doctors do when they're trying to have a diagnosis. They kind of unconsciously use their expertise, and then they go ahead and they pull out those specific things that they think, and then they test and disprove their hypothesis and what's going on with the patient. Okay, some other obstacles besides availability and representative heuristics is fixation and functional fixation. There's a really famous study that they did and a video you can watch. It's up in the right there, the candle tray problem that they had. They gave people tacks, a box, and a candle, and you had to get the candle to stay on the wall. And people were so fixated on what each of the objects' purpose was that they didn't realize that the box of tacks could actually be taken out. Like you take the tacks out of the box and then you use the box as a shelf. And then you put the tacks into the wall. People were trying to tack the candle to the wall with the tacks and all kinds of things. And so they got fixated on what the function of a object should be because of their own kind of sets. This was the other example, was the plarn, the plastic yarn made from plastic bags. Plastic bags are not just trash, but they can also be made into mats for the homeless and so forth. So just the idea that people who are thinking outside of the box are not being limited by their function fixation and so forth, and that's important. Mental sets also kind of keep you from solving a problem because you're very rigid in our insights and so forth. And your own rule of thumbs can kind of like keep you from moving from into a new behavior because you're so fixated on what your past kind of things that you've used to solve problems. So you tend to persist in problem solving the way you did in the past. And that's why people kind of with the functional fixation, they have a hard time like, okay, I've solved this kind of problem before and this is how I solved it, and they just can't get out of that. And it maybe that's kind of an example you can have with math. Is there something in math where you've just constantly solved this problems this way and you just can't get out of that rule of thumb or heuristic that you've had in the past? Okay, other kinds of decision-making strategies, single feature model. And this is to simplify your decisions you based on a single feature and so forth. And it works if you're doing like a simple decision, like buying the cheapest detergent, okay? That's easy because it's the cheapest, right? Or is it the smells the best? Or is it have the most volume for the money? So you pick one specific thing that you base that feature on. Something like additive model, you have generate a list of factors that are important. So unlike the single feature, we put all different alternatives and we build up a scale, and there might be ratings for that, and then we have choices and so forth. So that sort of improves your decision-making process because you go through a certain thing. And you don't have to do that with buying a detergent per se, although some people do and they get very analytical. But choosing a college roommate or somebody like that wouldn't be included in that because it's so many different choices and different features of a person that you could use to compare. Okay, and then also there's the elimination by aspect model, okay? And this is considering alternatives one at a time and starting with the feature you consider the most important, okay? And then you narrow down that list of choices and alternatives. And it's used for complex decisions and multi-feature comparisons like buying a new computer or a TV might do that. And it's related to the additive model, but this one, we really think of what's the best feature, like what are you looking for, like, and you may do that with a college roommate, what's the one thing you're trying to look for in a person, but you certainly wouldn't eliminate a certain feature of a person off of a list. So if, for instance, the price was really the most important, but then you were losing a bunch of things because the price wasn't allowing you to get certain features on your TV, then you would take off that alternative until it met, you know, the criteria or so forth. So maybe money wouldn't be the number one, and you kind of take that alternative off. You may not do that when you're trying to get a college roommate, because all of those things might be the most important for a college roommate. So it depends on what you're actually deciding to do. Overall, good decision makers adapt their strategies to the situation and often use more than one strategy, like I said. So again, you could be starting with the elimination model and then narrow down and use the additive model, where all of the choices for the TV are the most important, and then you decide which TV actually would be best at that point. So again, you have maybe been working alongside me talking, but now you need to go back and for each one, write each of those definitions in your own words. Again, elaborate rehearsal, and then give yourself a self-reference example, which is also part of elaborate rehearsal. All right, good luck with everything, everybody. Bye.